I will explain the concept of square root of a number and cube of a number, okay? So in our previous lesson, we have seen concepts such as squared values of a number and the naming associated with squares. Do you remember what a square of a number is mean? All right. The square of a number is a number multiplied by identical factors, okay? Whenever you calculate any number, you calculate that number by itself. That is what we mean by squares, okay? We have also seen properties of a square of a number, okay? Do you remember what the properties looks like? Good. For any rational number A, one of the properties that we have seen in our previous lesson was the squared value of any rational number is greater than or equals to 0. This was one of the things that we have seen before. The other thing is we have seen A times B the whole square is A square times B square, where these A and B are an element of rational number. Okay, this was the second property that we have seen in our previous lesson. The third one is if we have two rational numbers, A over B the whole square is A square over B square, where here B is different from 0. Okay, unless B is a number different from 0, this fraction will not be defined. So this was the other property that we have seen in our previous lesson, okay? So we have also seen some examples and some tricky approach to calculate the difference between the squared value of some consecutive numbers, right? So based on those things, I have also asked you a homework. Do you remember what the homework looked like? Have you tried the solution for all of the 4 questions that I have given before? Well, I hope you did all the questions. So saying this, I will start the present lesson, okay? Here, we will talk about the square root of a number, okay? Square root of a number. So let's see the definition of a square root of a number before we start some of the examples regarding this topic. So when we come to the definition of a square root of a number, let A and B are an element of rational number with a condition A square is equals to B. If we have two rational numbers A and B with this condition, then A is called the square root of B. Then A is called the square root of B. Calculating a square root of a number is the reverse operation of squaring of a number. As you remember, we have seen how we can calculate the squared value of a number. Here, when we come to the square root of a number, this process is the reverse operation of the squared value of a number. So let's see examples. Calculate the square root of the following numbers. The following numbers. The first one take 4, and the second take 9, The third takes 16. Now let's see how we can calculate the square root of these numbers. Okay, before I start calculating the square root of the given numbers, I will repeat the definition that we have here. Always, if you have two numbers a and b, a square is equals to b means a is square root of b. So we will apply this definition to calculate the square root of these numbers. So let's start from a part. Okay, in a we have 4. 4 can be written as 2 times 2. Okay, 2 times 2 is 4. At the same time, 4 can also be written as minus 2 times minus 2. Okay, the product of any two negative number is positive, and the product of 2 times 2 is also positive, and the result is 4. Okay, so based on the definition, we can rearrange 4 in this manner. Okay, 4 can be written as 2 square, or 4 can be written as minus 2 square. So 2 or minus 2 is the square root of 4. Okay, this is how we calculate the square root of a number. When we come to the b part, we have 9. Okay, so the first thing that you need to do here to calculate the square root of 9 is you need to rewrite this number as a product of two identical numbers. So can you guess how we can write 9 as a product of two identical factors? Well, 9 can be written as 3 times 3. This is one way. Equivalently, we can also express 9 as a product of two linear factors, like minus 3 times minus 3. Okay, both this product gives us the same number 9. So 9 can be expressed as 3 square or minus 3 square. Okay, so 3 or minus 3 are the square root of 9. Okay, so here in a part, 2 and minus 2 are the square root of 4. You can write in this way. I told you this thing orally. Similarly, you can answer minus 3 and 3 are the square root of minus 3 and 3 are the square root of 9, right? Similarly, we can write 16 in this form. So when we come to the C part, 16 can be written as 4 times 4. And also we can express 16 as a product of another identical factors, like minus 3 times minus 3. I mean minus 4 times minus 4. So 16 can be expressed as 4 square, or 16 can be expressed as minus 4 square. It's possible to express in any of this form. Therefore, we can see that minus 4 and 4 are a square root of 16. Okay. So similarly, you can calculate the square root of a certain number by converting that number as a product of two identical factors. That is how we calculate the square root of a number. Here, I want to tell you some exceptions. For example, if we are asked to calculate a square root of radical 4, radical 4 is only 2. Okay, this is a principal radical, okay, a principal square root. Okay, the principal square root of 4 is only 2. But if you are asked to say, or to respond the square root of a number in verbal form, square root of 4 is 2 or minus 2. But this is radical 4 is only 2. Because this radical is a principal square root, you can only take the positive part. Similarly, square root of 9 is taken as only positive 3 because this is a principal square root. Similarly, the same thing for 16. Okay, so this is how we calculate a square root of a number. Now let's see other ways of calculating a square root of a number, okay? Approximate the square root of a number. Look, in the previous example, we have seen how to calculate the square root of a number. Sometimes we may not directly obtain the square root of a number. That is common, okay? So in this case, we use approximations to calculate the square root of a number, or we use a table of squares, okay? In your textbook, at the end of your textbook, there are tables containing squares and square roots, okay? So here, I'm going to tell you only how you can approximate the square root of a number without observing your table of squares, okay? For example, if you are asked to calculate radical 5. Calculate radical 5. If you are asked to calculate radical 5, you cannot express 5 as a product of two identical factors. So it's impossible to obtain a certain exact number. So in this case, we use approximations. Look, clearly 4 is a number less than 5. And 5 a number less than 6, you can make it 7 or you can make it 9. For some convenience, I took 4 and 9. Clearly, 5 is a number between 4 and 9. So if we take radical in each side, okay, if we take radical in each side, the inequality will not change its direction because all these are positive, okay? So we all know that square root of 4 is 2 from the previous example. Square root of 4 is 2. This is less than radical 5. And radical 5 is less than square root of 9. Do you remember what square root of 9 is? In our previous example, I have shown you how you can calculate the square root of 9. So clearly, square root of 9 is 3. Now we can assume, or we are sure that radical 5 is a number between 2 and 3. That means it's 2 point something, okay? To get a better approximation of radical 5, you can take numbers like 2.2, okay? Take the squared value of 2.2, you will get 4 point something, okay? Okay, whenever you take a number very close to 5, that will be your approximation, okay? You can calculate 2.2 the whole square and 2.3 the whole square, okay? The one which is better, or the one which is more closer to 5, can be taken as a good approximate value of radical 5. So here I'm telling you some more general approach. Just like determining where that number is found, okay? Radical 5 is roughly a number which is found between 2 and 3, so it's like 2 point something. To know the better approximation, you can also use table of squares from your textbook on the back side of your textbook. Roughly, let me tell you one more example on approximating a certain radicals. For example, if you calculate or approximate, not calculating, approximate radical 31. Okay, please take this, calculate by approximate, because we are not calculating, we are approximating. So if you are asked to approximate square root of 31, here approximation is required because we cannot write 31 as a product of 2 linear factors. So it's a must to approximate or to assume a certain number which is very close to this. So whenever you are approximating numbers like radical 31, think of some perfect squares, okay? Where is 31 found? You need to find 2 consecutive perfect squares in which 31 is between them, okay? So you can take 25, okay, one of a perfect square. The next perfect square that comes after 25 is 36, okay? So now clearly 31 is a number between 25 and 36. So you can put it in the middle of these 2 numbers, okay? So you can take 25 is less than 31, 31 is less than 36. This is the first thing that you need to do in approximating square root of 31. So the next thing is we take this inequality, okay? We take this inequality and use radicals in each side, right? Radical 25 is less than radical 31. This is less than radical 36. Since 25 and 36 are numbers that can be taken out from the radical, this gives us 5 less than radical 31. Radical 31 is less than 6. Okay? This is a rough approximation of radical 31. Students, you will learn more about better approximations on some radicals. But at this stage, I'm telling you how you can roughly approximate radical 31. So obviously, radical 31 is a number between 5 and 6. Okay, good. So next, we will have a discussion on cube of a number. Okay, so far we have seen how we calculate the squared value of a number. We have seen how to calculate the square root of some number and approximating some radicals, right? This was what we have seen. So now we will see cubes and cube roots. Cubes and cube roots. Okay. So a cube is defined in this way, okay? A cube is, a number cube is the product of 3 similar factors, okay? So the product of any 3 identical factors is called a cube, okay? So this is the first definition that we have in this topic. A cube is obtained by multiplying 3 identical numbers. Okay, there is a difference between a square and a cube. A square is a number, a product of two identical factors or two identical number, and a cube is obtained by multiplying three identical factors or three identical numbers. For example, 1 times 1 times 1, usually we write this 1 to the power of 3. The product of these three identical numbers is 1. Okay, this is an example of a cube. Let me give you some more simple examples of cubes. Take 2 times 2 times 2, which is usually written as 2 to the power of 3. Okay, this is the product of three identical numbers, and this is called a cube. So 2 cube, usually 2 cube is 8, because 2 times 2 is 4, 4 times 2 is 8. Okay, you can also take some more examples on the cube. Say minus 5 times minus 5 times minus 5. So this is shortly written as minus 5 to the power of 3. Okay, this is also an example of a cube. If you are asked to give the result of these three products, minus 5 times minus 5 is positive 25, and positive number times negative number becomes negative. So the product of these three identical factors gives us negative 125. Here we use a notation. A to the power of 3, meaning that a times a times a, right? Okay, you cannot, it's possible to write in this form, but to make it easier, you can write the cube in this form. This is a formal way of writing a cube of a number. Here, you need to avoid these kind of things. A cube is not 3 times a, okay? This is not the correct way of expressing a cube. You can also take the square issues. Whenever you calculate the squares, a square is not 2 times a, okay? This is not true, okay? A square is a times a. This, if you are writing in this form, you are doing a mistake. This is true only whenever a is 0 or whenever a is 2, okay? A square times a or a square is different from 2 times a. Okay, so here, this works, a square is equals to 2 times a works whenever a is 0 or a is 2. Otherwise, for other values of rational number, this do not work. So that's why I was not writing this as a property. Okay, you need to avoid this kind of mistake because this is something commonly appearing. Okay, avoid this thing. So whenever you come to the cube part, a cube doesn't mean that 3 times a. Okay, you don't multiply the power with its base. Probably these two will be the same whenever a is 0. So let me give you some more examples of a cube. So if you are asked to calculate 2 over 3 the whole cube, okay, 2 over 3 the whole cube means multiplying 2 over 3 how many times? 3 times, right? So 2 over 3 times 2 over 3 times 2 over 3. Okay, this is the product of identical rational numbers. So during multiplication, the only thing that we do is we multiply numerators with numerators only and the denominators with their corresponding denominator. So 2 times 2 is 4, 4 times 2 is 8, okay? And the denominator, 3 times 3 is 9. 9 times 3 is 27. So the cube of 2 over 3 is 8 over 27. Okay, so the procedure works for every rational number, but whenever we have rational number in mixed form, in mixed fraction form, like 2 and half, the whole cube. If you are asked to calculate this, the cube of this mixed fraction, always convert the given mixed fractions into improper fraction. That is the first step. Then you keep working the way we do for the previous numbers. So what is the equivalent form of 2 and half? Or what is the improper fraction form of 2 and half? Well, 2 and half is given by, or its improper fraction form of 2 and half is 5 over 2, the whole cube, right? So this is the first thing that you need to do. Then the next thing is, we are calculating the cube, meaning that you need to multiply this number, the base, 3 times. So this becomes 5 over 2 times 5 over 2 times 5 over 2. Okay, multiply all the numbers on the numerator together, and this becomes 5 times 5, which is 25. Multiplying it by 5 gives us 125 over 2 times 2 times 2, 8. Okay, so this is how we calculate the cube of a number. Okay, sometimes we have also other ways of representing a cube. Okay, but I will come back other ways of I will tell you the other ways of representing a cube of a number. But before that, let's see how we can approximate the cube of a number. Approximating a cube. Okay, in our previous lesson, we have seen how we approximate the square of a number. Okay, because of the rigorous step, we can use approximations to minimize the calculations or the steps that requires. Okay, so when we come to approximating a cube, the first thing we do is we round the number to the nearest integer, then we keep working on cubing, right? For example, approximate the cube of the number x below. Okay. We have numbers like 2.8, x is equals to 2.8. The other number, x is equals to minus 4.4. And numbers like x is equals to 5.6. Okay. Here we have decimals. For each of these decimals, we are asked to approximate the cube of the following decimals. Okay, in approximating any decimal, we use rounding off, okay? So you need to use the principles in rounding off. So whenever we take x is equals to 2.8, the approximate value of this number is x is 3, okay? X is approximately 3 because this is 8, which is a number greater than or equals to 5. So you need to add 1 on the integer part. So x is approximately 3. Here, after taking the approximation, we need to calculate the cube of these numbers. So if x is approximately 3, x cube is approximately 3 cube, okay? So 3 cube means multiplying 3 times, okay? So 3 times 3 times 3 is 27, okay? This is how we approximate the cube of a certain number, particularly those of rational numbers. When we come to the second part, we have x is equals to minus 4.4. So using rounding off, x is approximately negative 4, okay? X is approximately negative 4. So x cubed becomes negative 4 cube, okay? X cube is approximated to minus 4 the power of 3. So minus 4 the power of 3 means minus 4 times minus 4 times minus 4, okay? So the product of these three negative number is negative because this product, minus 4 times minus 4 is positive 16. Multiplying by a negative number, the result is negative. But what is that negative number? Can you guess the final outcome of the product of these three numbers? Well, 16 times minus 4 will give us negative 64. Negative 64. Therefore, the approximation of the cube of minus 4.4 is negative 64, and you need to use this symbol, okay? X cube is approximately negative 64, okay? So don't forget to use this symbol, okay? You all remember the symbol for approximation. This is equal, and this is approximate values, okay? So this is the second part, or the B part. When we come to the C part, we have x is equals to 5.6, and we are asked to calculate the approximate value of the cube of this number. Okay, as we did here, x is equal to 5.6 is approximately x is equal to 6, okay? So the cube of this value is approximately 6 cube. 6 cube means 6 times 6 times 6, okay? As you can check, the result becomes 216. So x cube is approximated to 216. Okay, this is how we approximate the cube of a certain rational number. Okay, so in this lesson, we have seen how we calculate the square root of a number, and we have seen how we calculate the cube of a number, right? We have also seen how we approximate the cube of a number, right? So these are the point of discussion for today. Based on what we have seen so far, I will give you a homework regarding this lesson, okay? So these are your homework. The first one is calculate the square root of the following. Here I need you to calculate a square root of 49. Square root of 49. A square root of 121. Square root of 400. Okay, calculate the square root of these numbers. The second one, calculate the cube of x if x is 7. If take x is equals to minus 10, take x is equals to 4 over 7. Okay, the second question is about finding the cube of a number. So I need you to calculate the cube of these numbers. The third one approximates the cube of the following numbers. So the first one is take 1.8, take x is equals to 1.8, take x is equals to minus 8.4, take x is equals to 0.3. Okay, so the third question is approximating the cube of these numbers. So I need you to attempt all these three questions. So this is all for today. I hope you got some important concept regarding square roots and cube of a number. At the same time, we have also seen how we can approximate the cube of a certain number. So this is all for today. Thank you for listening.
Tamsaasa barnoota televezyiinii walta'iinsa Addis Miidiyaa Neetworkii fi biiroo barnootaa magaalaa Finfinneen qophaa'e chaanaalii keenya AMN Pilaasiin isin bira